So if you were to draw your number line, notice, say you drew your number line, okay, so let me just simply draw something like this. I have a huge number line, okay, so let me make some marks here to say we have a number line that's infinite. Somewhere here is a 0. All right, that's good. Now, plus minus. So somewhere on the right hand side is positive square root 1 over 2. Somewhere on the left hand side is negative square root 1 over 2. All right, so negative square root 1 over 2. It's slow going writing by hand. And this one is positive square root 1 over 2. All right, looks good. Now, that gives me 3 different pieces. One piece, another piece, another piece, and another piece. Did I say 3? No, wrong. 3 cut points gives me 4 pieces. 1, 2, 3, 4. Okay, these are the pieces you need to look at. All right, what are these pieces? Now here is negative infinity, correct, until, oh, maybe I can use mathematics symbol, can't I? That would be nice. Negative infinity, right, until negative square root 1 over 2. Let me write it in fractions so it's better to see what's going on. All right, so that's one piece. That's one interval. What's the next interval? Negative square root 1 over 2 until 0. Okay, so open interval, cut and paste because, oops, what happened? Open interval, this guy, until 0. That's the second interval. The third interval is 0 to square root 1 over 2. Okay, open interval. And the fourth interval is square root 1 over 2, oops, open interval, square root 1 over 2 until infinity. Okay, so these are the 4 intervals. Let me write that down. Okay, when you look at intervals, you only look at open intervals for these purposes. Okay, now let's take some test points. Okay, why test points? Let's figure out. So give me a number from negative infinity to negative 1 over 2. Get any number. Like I will take something large, right? It's not necessary. You could have taken negative 1 for all you care, right? Because this is going to be a fraction. You can check in your calculator. This number is going to be a small number, less than 1, greater than negative 1, okay? Now, take a number in the second interval. That's here to here. That's a small number, 0.5. Now, this is supposed to be positive. So, and on the right hand side, positive 0.5. And on the rightmost interval, I will take positive 1. These are test points. Why did I use test points? I want to figure out sine of f prime x. Okay, so let's go back to what was f prime x. F prime x was 4 minus 2 over x squared. Okay, so this is what we need to do. All right, so I need to find what happens here for f prime. Plug in -1 here. -1 becomes squared. 4 minus 2 over +1. 4 minus 2. I don't care what it is positive. Another way of saying this, greater than 0. All right. Now, -0.5. If I plug in there, I get 4 minus 2 over square makes the sign go away. So 4 minus 2 over 0.25. Okay. So that gives me 4 minus 8. That's a negative. Negative means less than 0. Well, if you don't believe me, check it yourself. You should be getting this. Now, 0.5, when I square it, well, it's 0.25. 2 over 0.25 is 8. 4 minus 8 is a negative, less than 0. Lastly, 1. 4 minus 2 over 1 squared is 1. 2 over 1 is 2. 4 minus 2 is a positive. Okay. Positive means greater than 0. All right. So far you got this. Now go back to your lecture slides. Remind yourself what this is. If f prime is positive, then f is increasing. If f prime is negative, so only the sign of f prime tells you whether f is increasing or decreasing. Let me get this aside so we are not encumbered by this. Okay. So if wherever f prime is positive, f is increasing. So this tells me the last part is f increasing or decreasing. Correct? When f prime is positive, f is increasing. When f prime is negative, f is decreasing. When f prime is negative, f is decreasing. When f prime is positive, f is increasing. All right, so these were the intervals you got. Now one more final picture. What happened here then? Let's compare it. Yeah. So if I want to understand what's happening here. In the first piece, f is increasing. In other words, I don't know where my graph is, but wherever it is, it's increasing. Okay? It reaches a certain height and then it decreases. Okay? At 0, I'm not defined. So I will not bother there. But I just want to know what's happening here. Likewise, on the positive side, 0 to square root 1 over 2, I am decreasing. So I don't know what's going on here. I may be above or below. I don't care. I'll just draw above. And then square root 1 over 2 onwards, I'm increasing. I hope this is clear, right? So I'm looking at sine of f prime. Okay. So first I am positive in this region. Then I am negative in this region. I am negative in this interval. I am positive in this interval. So that's what f prime is doing. So I'm increasing here, then decreasing. Decreasing here, then increasing. I don't care where the graph is, above or below. I'm just telling you what the shape is, correct? So once you know that, what does it say about negative root 2? Negative 1 over root 2, it's going to give me a local max. Positive 1 over root 2 is going to give me a minimum. All right, so that's the picture here. So let's figure out how to write this. I need to see this picture, and too many browsers. Get rid of that. Okay, now I can see. So where is it increasing? They want us to write U for the union symbol. So I will say open parenthesis, negative infimum, negative square root 1 over 2, close, close. Union means you're increasing there and increasing there. So there are two pieces you need to go for. Okay. The other one is square root 1 over 2 until infinity. Where is it decreasing? Negative square root 1 over 2 until 0, and a union 0 until square root 1 over 2. Don't forget to close all the parentheses. Local maximum. I get a local maximum here. Negative square root 1 over 2. And I get a minimum here. So positive square root 1 over 2. Okay. All right, guys. Until next.